Hey, good morning, Algebra 2. Today we're doing properties of log. So go ahead and open your books to page 884. Date and title your notes today, 12.3 properties of logs. Okay, so these properties of exponents really correspond to properties of logs. And I just want to remind you guys from the product rule, if you have the same base, and you're multiplying, oops, I already messed it up. There we go. B to the m times b to the n. So two things that have the same base with an exponent, if you're multiplying those, you essentially just add the exponents, then it would be b equals m to the n. And I know that looks a little arbitrary just with some letters, so let's try it with an example here. Say I was doing x squared times x cubed. We're not, x, there we go. We're not multiplying, we're multiplying the x's, but you add the exponents. So saying x to the 6th would be wrong here. X to the 5th, remember you add the exponents when you're multiplying the same base. So this would be x to the 5th. There. Okay, so something similar happens when we're working with logs. We have the product rule with logs. So we're going to use b for our base again, just like I used b as this base. So it's going to be the little base on the log now. So if I have log of base b, and I'm multiplying an m times n, okay, get that into your notes. We can kind of, I say like expand it. So I'm going to separate that m times n right there gets to be split up. Just like if I worked this backwards, I started with x to the 5th, and then I could kind of split it up to x squared times x to the 3. And what pattern we see, what happens when we do that for a product rule with logs, is that you get log base b big M plus log base b big N. Copy that down. Now this is a green box in your book on page 884. This is a rule that I want you guys to box and star and memorize and highlight, tab it in your book if you do so, please. Okay, so it's the sum of the logs. Okay, sum of the logs. It ends up, right? Sum plus sign, the sum of these logs of whatever the log base b of n is, plus whatever the log base b of n is, okay? And that would be the product rule for log base b of m times n there. Okay, we can give that a little label, product rule, and a reminder for ourselves, this is on page 884, just so we have those notes. Okay, so let's try one. What does it look like when we do this? So your first example here, we've got, let's do example 1 out of the book. We've got log base 4, 7 times 5. Copy that into your notes, bottom of 884, and it's here on the screen for you. So I'm copying that rule that's written directly above it. We're going to expand it with equals. Log, what's our base? The small number, the little b is a 4. And our m is 7 plus sign, log, same base, still the little 4. Base does not change. And then the big 5. There we go. Okay, copy down, make sure you have that into your notes. Okay. Now in the future you may take things, you may do another step or do something else with this, but right now this is all we're doing, product rule. Okay, let's try one more. What if we throw a variable in there? Let's have an x in there. So let's do a log, and I'm not going to give you a base, or am I? So we're going to do log of 10x. Take a look at this. Well, what's my base? What's my little b? It's invisible. It's gone. Now, I know we always say if there's no number in front of the x, that it's a 1. That's not the case here. So don't assume. That would be a good assumption. That'd be using your reasoning skills from what you've learned so far, be a good guess. But actually with logs, we have a common log or like standard log. It's always a 10. So it's a standard 10, base 10, and it's understood, it's assumed that it's a base 10. So, and you will get problems like this, not just in my class, in future math classes. So if there is no number, you can go in, if it helps, and I'm going to use a different color because it wasn't really given to us. You can put in the little 10 there. Put in a little 10 there. So we know it's assumed that that is a 10 if there's nothing there, always. That is the common base. Let's see what the book says about it. We've got blue font about it on the top of 885. Read with me. The log of a product is the sum of the logarithms. The logarithm is a product. The logarithm of a product is the sum of the logarithms. These are common logarithms with base 10 understood. Because log base b of b equals 1, then log base 10 equals, log of 10 equals 1. Log base 10 equals 1. Okay, and I'll write those out real quick, just that little, here's why. So we have common base 10, and why? Because of log base b of big B equals 1, and log of 10 equals 1. So we have these very standard things there, okay? So our common base is 10. If there is no base written, you know and you assume that it is a 10. And then we have these two very kind of standard things that we need to write down. Log base b of b is equaling to 1, and log of 10 equals 1. And really you know that there's an invisible 10 sign right there, a little base 10, invisible base 10 right there. So it's log base b of 10 equals 1, right? So it does have, that's like this being a 10 and that being a 10, but we don't have to write the teeny tiny base 10 there, okay? All right, let's move on. So we did the product rule, so multiplication. What do you think we're going to do next? If we did multiplication, let's do division. So product rule, we're moving to quotient rule. So skip a line in your notes, still the same section, but skip a line, the rule is different. So we have our quotient rule. This is also in your book and the green box on page 885. So let's get it down. We have, when you have log base b and something divided by something else, right? That's a quotient. Quotient line, you may call it a fraction or a quotient line or, you know, whatever. And, you know, we could get crazy later on. It could even be a polynomial and a polynomial there and there. But for now, it's m over n, whatever that m is and whatever that n is. When we kind of expand this log, you keep the same base, and that quotient line turns into a subtraction sign. Just like back here, that multiplication sign, when we expanded the logs onto each of those numbers, that multiplication sign right there, invisible multiplication sign, turned into a plus sign over there. So now, that quotient line, we're going to expand the logs, write them twice, same base. That quotient line turns into a minus sign. Okay, write that down into your notes now. It's also in the green box in the book. Log base b of m minus log base b of n. So this is now the difference, right? Subtraction sign means difference. So this is now the difference of the logs of m and n. Keep the same base, whatever that base was. Could be a base 2, could be a base 10, could be a base 15, whatever. Keep it the same. Okay, so that's a rule. Box it, star it, put a tab in your book if you do so wish. There we go. That's our quotient rule. So let's try an example of it. Say we have log x over 2. Log x over 2. So that's our quotient. Looks like a fraction, or it could be 1/2 x, right? We put the 2 in the bottom there. 1/2 x or 0.5x. There's no base. What does that mean again? That means our little b is a 10. Now you could pencil it in a tiny, in a different color, or just leave it blank and you just remember and assume and know that that is a common base 10 that is there. And we don't have to write it again. So when we expand it, I can just leave it as a log. Log big X minus log big 2. Now I could go in and write in little 10s right there, and right there. And if that helps you, awesome, do it. But you don't need it. It is assumed that that is a 10 there. Okay, and you will see problems given to you this way where there's no base provided. And you don't have to write your answer with a base because it is just that assumed invisible 10. Okay. All right, so now let's try one with a base. So let's do a log base 7. Log base 7, we're going to do 19 over x. Let's see what that equals. All right, so following that rule above, let's expand it. Keep the base of 7, and that quotient line turns into a subtraction sign. We're going to write the log twice. You're expanding that log out twice. Write it twice. So log 7 of the 19, the numerator comes first, the numerator, and then the denominator, you're subtracting the denominator. Just like you were dividing by the x, now you're subtracting the x. So log base 7 of x. So the order here matters. Order here matters. If I switch that 19 and x, then this would not be equal. Those would not be equivalent things. It's 19 divided by x. When you expand the logs, it becomes 19 minus x. If you flip-flopped x and 19, it would not be the same problem. So top divided by bottom. So that's top minus bottom. Okay? Keep that in mind. All right, and then we're going to throw you guys a crazy left hook. What about this thing called natural log? So let's do that. So next example we have natural log of e cubed. Whoa, an e. Natural log of e cubed over 7. Okay. Well, expanding it, don't be scared. Just expand it the exact same way that you've expanded the others. So we've got our other examples there. Expand it the same way you have. So natural log, I want you just to picture that as, think of it just as like a log. So natural log of e cubed, quotient line, so then we're subtracting natural log of big 7. Okay, we're expanding it, follow the same exact quotient rules to expand it, okay? Make sure you copy that down into your notes. Okay, so the only thing that's different now here, so if you have a log, just a log with no base, you know that it's a base 10. So the book doesn't do a real good job showing this, so I'm just gonna make something up here. So we know a log with no base is a base 10, and we know a natural log with no base, this is crazy, is a base e, okay? So up here, there was no base, you know and assume, and just remember, it is a 10 if there's no base. If it is a natural log, that is a base of e. If there's nothing there, that is a base of e. What was e again? Grab your calculator. You've got your E button is, there's a couple versions of it, above the division sign right there. So press your second and then your division sign, and that gives you the E key, just like you get the pi key. Hit enter, and we have this irrational number. It does not terminate, it does not repeat, it goes on and on like pi does, right? You also have pi, so right above the division sign, so 1 up, you've got pi, so hit second and pi. Same business, okay? So pi 3.14, e 2.72. So those are always on your calculator. If you ever forget them, you've got a calculator, unless it's, you know, the non-calculator section of your exam, but so E, so natural log of base e. And then we have a couple things, just like we had the rule reminder on the last page. So e to the x is the same as x. And this is a rule back, I don't know, a few sections ago. I don't know if we really hammered it hard enough, so I want to mention it again now, that e to the x equals x, right? And that's just like saying, you know, it's just a rule, okay? We just got to know that one. So if that's true, then e cubed, if that's my rule, if e to the x equals x, what's e cubed? 3, right? That follows the rule. So e cubed will just be 3, okay? So knowing that, this problem, I can actually take this problem a step further. I can take this a step further. So when we have, let's find it again. So natural log of, sorry, should put a natural log in front of that. So it's natural log e to the x, sorry. Natural log e to the x equals x, and natural log of e cubed would then equal 3. That's the rule. Sorry, I forgot the natural log out front. Natural log of e to the x minus equals x, and natural log of e cubed equals 3, okay? So we have this rule, natural log of e to the x equals x, natural log of e cubed then, following this rule, would equal 3. So this right here, natural log e cubed, we can replace with a 3. So this right here gets replaced with a 3, okay? Following this rule here, I've plugged into that rule, shown that in green, so that right there gets then replaced with a 3, okay? And then minus natural log 7, we can't really do anything with that right now, so that just subtract natural log 7, okay? Let's just copy that down, minus natural log 7, okay? And that is our answer for our third example here. Natural log of e cubed over 7 equals natural log e cubed minus natural log 7, and then we simplified natural log e cubed is equal to a 3, so we replace that with a 3, and that's just where we stop for that answer. 3 minus natural log 7. Okay? All right, so you're going to have to do a few of these and do maybe a little converting around things with that. Just to throw up 2 real quick examples. I won't spend as much time going through, but I want you to have another visual of what a quotient rule expanding looks like with a log. I'll do one more with log and with natural log and one with log. So let's do log base 8 of 23 over x. So I'm going to keep the same base, expand it, that quotient line turns into a subtraction sign. So we'd have log base 8 of 23 minus log base 8 of x. Log base 8 of 23 minus log base 8 of x. And then we take a quick look. Can I simplify either of those things that are we're taking the difference of? No, can't really combine or simplify or do anything. So you leave that, that's your answer there. One more quick example with this of a natural log. Let's take natural log of e to the 5th over 11. Natural log of e to the 5th over 11. So following our same quotient rule, how do you expand it? Same thing. Natural log, that's an ln, natural log of e to the 5th minus natural log of 11. Write it out. Okay. Now, we've expanded it, natural log e to the 5th minus natural log 11. Can we simplify either of those? And yes, we can. This one right here fits into this natural log rule from a while ago. So if I have natural log e to the 5th, it's going to equal 5, right? Natural log e to the x equals x. Our example, natural log e cubed equals 3. So if we have natural log e to the 5th, it's going to equal 5. So replace that with a 5. And then we can't simplify that natural log 11 right now. So it's just 5 minus natural log 11 is your final answer. for that example. Okay. Got just a couple more here, or one more. We've got the power rule, So let's do green box, top of page 886. The power rule, we have log base b of m raised to the p. Okay, right there. Log base b, big M raised to the p. This rule, really all it says, it's a cool rule. It makes things easier. I like it. You just take that p, that exponent, and bring it out front. You multiply it out front of the log. That's it. It's really cool. I like this one. It helps you a lot. It's like a shortcut in problems. So that p, you literally take the exponent, tiny raised exponent p, and bring it out front, and you make a big, multiply it onto your log. So now it's a p times log base b m. And that is your power rule. Okay, so we're allowed to do that. We like it. It's easy. Makes life easier. So most basic example, and I would honestly just memorize this. So if you have, let's say, natural log x squared, it's not an e, can't simplify it to 2. If that x were an e, then I could simplify this to a 2, but it's not. So natural log x squared, my exponent, my base is still an invisible little e because it's natural log, so there's an invisible e. That doesn't really change anything. I don't need to write it in. So the exponent, the p, is the 2. So that 2 gets to be brought out front of here, and it's a big 2 times natural log of x. You don't have to write the times sign. We know that it's there. It's assumed. So 2 times natural log x, and that's it. Okay, most basic example of that. So let's try a couple of these. So let's see real quick. We've got, if you had log base 5 of 7 to the 4th, whew, and we're just simplifying, we're rearranging. Remember, rearranging things really helps us solve and simplify things. And yeah, you could put x to the 4th in your calculator and get a really big number, but that's not actually going to help us right now. It's not what we're looking for. Just take that 4 and put it out front. Big 4 times log base 5 of 7. There you go. Okay. And I'm going to bring in radicals. I want you to never forget that a square root is the same as a 1/2 exponent, right? Anytime you see a square root, and this will come up next year for you guys in math, anytime you see a square root, remember we don't really like radicals. They make life harder. We especially don't like radicals in the denominator. Anytime we get a radical in the denominator, whoo, we try and get rid of that first thing we can. We rationalize the denominator. We do what we can. So similarly, we would much rather have this as an exponent. And you guys know, what is a square root as an exponent? 1/2. So let's change that. So that x, it's no longer a square root x, it's x to the 1/2, right? You guys know that. Just got to remember back a little bit. Just like the cube root of x would be x to the 1/3. Okay, yeah, it's starting to come back now. Okay, so we prefer the exponent, even though it's a fraction. It's because now kind of fits our rule, right? That 1/2 fits into the spot of the p now. So that 1/2 now can be brought out front. So let's do it. It's now a big 1/2 times natural log of x. And it's a lot easier to work with and take that problem further, as you will in the future. You're just learning the rules for the logs. These are the properties of logs, which you do need. And they'll get applied in even up in calculus. You'll apply these exact same rules, and instead of logs, you'll be using integrals. Fun stuff. Okay, so big 1/2 natural log x. Okay, last one. What if we have a couple variables in there? What if it's not just a 7 or just an x? Let's do a 4x. Okay. Parentheses are our friend. They tell us so much information. So that the parentheses are around both the 4 and the x. That means both the 4 and the x are being raised to the 5th. That's like 4 to the 5th times x to the 5th if we were to rewrite it, okay? So since both of those things are essentially the m, that p can be brought out front over there. 5 log 4x. And keep the parenthesis around the 4x, okay? Because it's not log base 10 of 4 then times an x. No, it's log invisible base 10 of 4x together, okay? So keep your parentheses around it. All right, I want to ask you guys if you have any questions. It's a little hard, the video, but you know, just email me if you have questions. I'm going to throw up 2 more real quick just so you can see what they look like. Say we have a natural log of that cube root x that I was talking about. I just want you to see it. You guys know that the cube root is the same thing as x to the 1/3, right? We can rewrite that as x to the 1/3. So if a cube root x is the same thing as x to the 1/3, that is your exponent that then can be put out front as I've done there. Okay. Last one, what if we have a binomial? Let's do log of the binomial x plus 4 squared. You could expand that for a quadratic, right? That looks like a quadratic. X plus 4, that's a binomial. Squared, you would FOIL it. X squared plus 4x plus 4x plus 16. Combine like terms, the O and the I. X squared plus 8x plus 16. Wow, it's quadratic. Okay, just want you to recognize what that is, but you don't have to expand it. What we're going to do is take that 2 and put it out front. And that, because that parenthesis covers the whole binomial, just like up here, the parentheses covered the whole 4x. So don't mess around with the things inside. Keep the parentheses. We like parentheses. They're there to guide us. So that 2 comes out front. We have a log, 2 times log, parentheses, x plus 4. Okay? All right. Those are the basics, and unfortunately you may have to apply 2 of those rules at the same time. So you might have to expand it. Let's see, actually, it's like this rule. This rule could be expanded. That's a 4 times x, so we could expand that. Yeah, let's do that. We've got a 5 log of 4. That's a times, so it turns into a plus, and we write the 5 log invisible base 10 again. There we go. The times turned into a plus. We wrote the log twice, keep the same base, which happened to be an invisible 10. We had a 5 out front. And we could even factor that 5 out. That 5 is in both terms. So we could factor it out as like a greatest common factor and have a log 4 plus a log x. There. See, we took out that 5 out of parentheses right there and then just did the log 4 plus log 5. Okay, so we applied 2 rules in that one. Okay. All right, and then any of these rules can go in reverse, right? We started with this quotient rule and we expanded it to that. Well, you can start with these 2 and go back that way. Same with the, here we go, product rule. You can start with these 2 and condense them to look like this. So I'll just show you one example of each of those going the other direction. And I'll set you loose to attempt your homework. So let's say we had a log base 4 of and big 2 plus log base 4 of a big 32. Okay, copy that down. So we're following the product rule in reverse. It's still the same thing. Our product rule in reverse would be log base b of m plus log base b of n equals log base b of n, m, there we go, m times n. M times n. So this is our product rule, and I just flip-flopped the left side and the right side on the equal sign. So here's our product rule, and you notice these fit. They're both the same base of logarithm base 4. So it has to be the same base to be able to combine these. If those were not both 4s, we would not be able to combine it. But they are, so we can do this, and that's a plus sign, which tells you they get multiplied there. So let's combine them. We have a log base 4, and then in the parentheses we have a 2 times 32. Okay? That's like our m, that's like our n, that's a plus, so they get multiplied. And then 2 times 32, can't we do that? Let's multiply those. So 2 times 32, we get our 64 there. And we have a log base 4 of 64. And that is our final answer there, log base 4 of 64. You could put parentheses around the 64, but there's nothing else there multiplied on the 64. There's not really a need, but you could. It wouldn't be wrong. It's just not needed. Okay. And then we'll do, let's do one of the quotient rule in reverse. So we've got, let's do log parentheses 4x minus 3. Ooh, and then another minus log x. Okay, so log of that binomial and then log of x. So I see 2 minus signs. What's going on? Is this like 2 quotient problems? Nope, take a look. Let's write down our quotient rule first. Write down your quotient rule. So you have log in reverse, which is log base b of m minus log base b of n equals log base b of m divided by n. So that is our quotient rule written out. And take a look. So this is log base b of m. So this binomial 4x minus 3 is the m. That whole thing. How do we know? The parentheses, right? We like the parentheses. Those guide us. So that set of parentheses tells us, because it's right next to the log. It's log and then the parentheses start. That means it's the m. Anything in these parentheses is the m, no matter how long that is. It could be a quadratic, it could be a polynomial divided by a polynomial, could have 2 variables, could be crazy looking. As long as you see a log and then the parenthesis starts, whatever's in that parenthesis, that's the thing, that's the m, okay? So don't worry about that minus sign. That's just part of the binomial that is our m. This minus sign, now that's the difference between the 2 logs. That's, say, log of this m minus log of that n. So that difference sign, that subtraction sign right there is what turns into the quotient line there. Okay, and what's our b? b is 10, don't have to write it. It's common, it's assumed. All right, let's write it. Log base 10. In the top, I have my 4x minus 3, and in the bottom, I have my x, right? That was my log of m. My m is that whole binomial. So that numerator is that whole binomial that I had parentheses wrapped around. Minus log x, that means now divide by, and the x, okay? That's our answer. We'd see if we can simplify it or anything if we can. In this case, we can't, so that is just your final answer, and you can box it. I'm just going to write quotient rule next to it and product rule next to the other one, just as a reminder there. Okay, so box the answer, wrote quotient rule next to the quotient rule that we rewrote in reverse. I wrote product rule next to the product rule that we wrote in reverse. Still the rule, we're just, rewriting it. Okay, that's about it. Okay, email me if you guys have any questions on this stuff. All your information about what the homework is will be in RenWeb. And again, this is our last chapter. Chapter 12 is the end, and then we're going to move on to reviewing. Next week will be all review for the exam the whole week. Of course, email me questions and upload pictures of your homework to the RenWeb homework job. Good luck, guys.